In our previous video 1.3, we had a brief introduction to ionic bonding. However, in this video, we are going to have a look at formation of ionic bond. Atoms that are always to form this type of bond will always have a change in their electronic configuration because they have to become charged particles. They have to become ions. In this case, for example, if we have a metallic atom, these ones are well known for losing electrons, and the due process they will form cations, which are positively charged because they will have more protons than electrons. However, when you look at nonmetals, for them they will always ionize and form the corresponding anions by a gain of electrons. In the due process, they will have an overall charge of minus because they will have more electrons than protons. So when you have a cation which is positively charged, and then you have a negatively charged ion, we shall always have a force between these two. And this force is the electrostatic force of attraction that we are talking about here. And it's this force that will always keep these different ions together, and it's what we shall call the ionic bond. Let us look at our first example, which is sodium chloride. We need to know how it is formed. Sodium chloride is also known as common salt or table salt, the one you normally add to your food to improve its taste. So whenever you have a sodium atom placed in chlorine, it can react, if at all it's hot, resulting into the formation of sodium chloride. So basically sodium reacting with chlorine to form sodium chloride, something like this. So let's balance with a half. Obviously chlorine will be a gas. So in this case we want to see how this sodium chloride is formed. So when you look at the two atoms, we have the sodium atom and the chlorine atom coming from the chlorine gas. So our sodium atom here has electronic configuration of 2, 8, 1. As you can see, this one electron is shown here in red. So this one electron, because sodium is a metal, will be lost so that our sodium atom can now become 2, 8. However, it will not be lost to no other atom. It will be lost to the nearby chlorine atom because we have placed this hot sodium atom in chlorine gas. So this sodium atom prefers losing this one electron so that it becomes stable. However, when you look at our chlorine atom, it has electronic configuration of 2, 8, 7, and it wants to obtain one electron so that it becomes 2, 8, 8, electronic configuration of noble gases. So in the due process, this one electron from sodium will be taken by the chlorine atom so that the chlorine atom gains one more electron to become stable. So when you look at what will be formed, we shall see that here we shall have new ions being formed. The sodium atom no longer has 3 energy levels. It now has 2 energy levels. This is energy level 1 and this is energy level 2. When you come back to our first image, it had 3. 1, 2, 3. But now because it has lost this outermost energy level, it now has only 2 energy levels. 1, 2. That's why here we are having a sodium ion. However, it has a positive charge as well. So at this point we have a sodium ion, Na+, while our chlorine also gained an extra electron. As you can see, it's red. It's the one that came from this sodium atom. So our chlorine atom will now become a chloride ion with Cl- because it will be having more electrons than protons, as we had seen in one of our previous videos, how we form ions from atoms. So whenever we have this cation which is positively charged and this anion which is negatively charged, opposite charges attract. So this attraction is what keeps these atoms together, as we are going to see in our next slide using a different example similar to chlorine. So that's all about sodium chloride. Basically, the sodium atom loses its one electron. However, this one electron is taken by the chlorine atom, so that they become 8 electrons in the outermost energy level of chlorine. But in the due process, the charges come into play, because when sodium loses one electron, it becomes positively charged, and then chlorine becomes negatively charged. Then these opposite charges attract and keep these ions together. Let us now look at the summary of ionic bonding using sodium fluoride. That means sodium is reacting with fluorine. When you look at this clip here, it shows that we have a sodium atom which initially has its outermost electron, and this outermost electron is then lost to fluorine. Fluorine, in the due process, it becomes stable, and they both obtain charges which are opposite, positive and negative, and then later on these charges attract. That means the positive and negative come together to form the ionic compound, which is sodium fluoride. So the same thing happens to sodium chloride. Just like sodium fluoride, we form sodium ion and the chloride ion, and then the two come together to form an ionic compound. In our second example, we are going to use magnesium chloride as our ionic compound to show how ionic compounds are formed. And in this case, we shall need one atom of magnesium coming into contact with 2 atoms of chlorine, which will be produced by the chlorine gas. So basically, we have magnesium reacting with chlorine gas to form magnesium chloride. However, one thing to note is that magnesium has electronic configuration of 2, 8, 2. So that means magnesium has 2 electrons in the outermost energy level, these ones here. And in this image, we have this first electron and this second electron. However, magnesium would love to lose these electrons, it being a metal. For it to become stable, it must have an electronic configuration of 2, 8. That means these 2 electrons have to be lost. And in this case, lucky is magnesium, because in its vicinity we have 2 chlorine atoms. And when you look at the electronic configuration of chlorine, we have 2, 8, 7. And there are 2 atoms. That means 2 atoms each needing 1, and then we have 1 atom which does not want 2 electrons. So what happens? Magnesium will lose 1 electron to 1 chlorine atom, so that it becomes stable, and the second electron to the second chlorine atom. So what happens is that magnesium will now become stable and obtain a 2, 8 electronic configuration, while these other chlorine ions or chloride ions will now be having 2, 8, 8, because they both obtained this 1 electron from magnesium. So in the due process, they will now become charged. We shall have a magnesium plus, as you can see, a 2 plus, and then the chloride ions will also now become negatively charged. So what exactly we are having? We shall be having magnesium with a plus 2 charge, and then we shall have 2 chloride ions that have a minus. So we shall have 2 chloride ions with minus. So these 2 chloride ions will be attracted by the magnesium ion, and in the due process, the forces that will keep these ions together will be the Coulombic forces of attraction, the ones caused by the negative charges and the positive charges. So these forces here will be our ionic bond. So that's how magnesium can form magnesium chloride whenever it's in contact with chlorine gas. During ionic bonding, there is transfer of electrons from the metal to the non-metal, forming opposite ions, and these ions coming together due to the attractive forces caused by the opposite charges. That's all about ionic bonding. Now let's have a look at our top 3 questions. Question 1. Which of the following is correct? Check through the objectives A, B, C, and D and let me know in the comment section. And question 2. The electrostatic force of attraction holds ions together. Is this statement true or false? Still, just note it down in the comment section and we see your say about it. Thanks for watching. If you find these videos helpful, don't forget to like, share, comment, and subscribe so that you don't miss any of our new uploads. In our next topic, we shall be looking at properties of ionic compounds. We want to know how sodium chloride behaves, how sodium fluoride will behave, magnesium chloride, and other ionic compounds. How do they behave in different situations? Be well.